I am approaching Soyuz.
Oh, please don't forget about your engine.
As the Cold War still burned, two spacecraft from opposing ideologies came together.
Contact.
The American Apollo crew emerged into the Soviet Soyuz, and the two commanders exchanged the first international handshake in space. While the mission was a technical achievement, it also heralded a new age in space exploration. Tensions fueling the space race were subsiding. A new age of collaboration was born. The goal of outer space began as an arms race.
It really was about superiority between the USSR and the USA.
After placing the first satellite into orbit, humanity sent one of its own.
It was an extraordinary act of bravery that Yuri Gagarin undertook. Humans could go into space and survive, possibly even thrive.
We developed new technologies and built shuttles to the stars.
Human beings need to travel, we need to journey, we need to explore. That's why we've gone out into space.
Building stations in orbit, we established a permanent presence in space.
It took a decade to actually create the full International Space Station. Once the first components had gone into space, you could put a crew on board. You could start to do the science.
As the Second World War came to a close, the United States and Soviet Union rushed to salvage Germany's scientific minds and the technology they had developed.
The space race really began, I guess you could say, out of World War II and the development of the V-2 rockets.
The world's first long-range guided ballistic missile, Germany's V-2, could cross the threshold of space.
Everybody knows there's this missile that can travel between continents, and it's been very successfully deployed in the UK and in Europe. And everyone knows there's a whole bunch of people with expertise.
US forces secretly evacuated thousands of German scientists and technicians out of Europe, far from the grasp of their communist former ally. The campaign was codenamed Operation Paperclip. A Cold War between the two ideologically opposed nations mounted. Each stockpiled weapons and the technical capability to deliver them. From America's perspective, the Soviets were too technologically backwards to develop a rocket capable of delivering a nuclear weapon to the United States. In 1957, the Soviet Union announced the world's first intercontinental ballistic missile, capable of carrying a nuclear payload 8,000 kilometers, the R-7. However, its enormous size proved impractical for warfare. The Soviet leader allowed his scientists to modify the missile to carry a satellite. Within weeks of the R-7's first successful test, the Soviets ushered in the space age. Bearing the Russian word for traveler, Sputnik climbed over 900 kilometers to the heavens.
The world was in anticipation that an artificial satellite would be launched, but everybody thought it would have the American flag on it.
A polished aluminium sphere measuring 58 centimeters in width, Sputnik's sole scientific instrument was a radio transmitter.
You are hearing the actual signals transmitted by the Earth-circling satellite, one of the great scientific feats of the age.
Sputnik transmitted a continuing series of beeps, which could be picked up by any person with the necessary equipment. Proof that the Soviet achievement was not fictional propaganda.
All over the world, people are tuning into the bleep, bleep of the satellite, which carries aboard the highly complicated mechanism necessary to transmit secrets of the universe.
It's a very characteristic beep, and I would love to know how much forethought went into that. For some, I'm sure it sounds inspiring. For others, it sounds kind of intimidating.
But to hear this artificial thing beeping and saying it above, I think put a real panic into some people.
And there was almost sort of hysteria, but at the same time, there was a fascination that humanity in some way had put this small object into orbit around the Earth, and thousands of people would go out each night to watch this tiny point of light travel across the sky.
It really triggered a huge interest in space that hadn't been appreciated in the wider population.
The space race was essentially here. It was not a pipe dream, it was reality.
The starting gun had been fired, and America was already behind. They quickly scrambled to place their first satellite into Earth's orbit.
In the universe, we know there is this thing called gravity. If you have something that's very massive, there's going to be a gravitational force pulling you towards that.
In the late 1600s, Isaac Newton conceptualized orbit using stones thrown from a mountaintop. The faster a stone is projected, the farther it will travel, before gravity drags it to the ground. But because the Earth's surface is curved, a stone projected with sufficient force would be pulled toward the Earth at the same rate the ground below is receding. Trapped in perpetual freefall, the stone would be in orbit. The United States Navy attempted to launch America's first satellite into orbit just 2 months after Sputnik.
Disaster follows, as this official film shows only too clearly.
Following Vanguard's failure, America's goal of space was handed to the Army. Wernher von Braun, the V-2 engineer snatched up during Operation Paperclip, would refine his Jupiter C rocket to deliver the satellite.
We've been assigned the mission of launching a scientific Earth satellite. And we will use the Jupiter C configuration as a carrier that we developed along with the Jet Propulsion Laboratory. I promised the Secretary of the Army that we would be ready in 90 days or less. Let's go, Werner.
They had to get something up there fast to show that they were still a major superpower when it came to space exploration.
Collaborating with the teams of William Pickering at the Jet Propulsion Laboratory and James Van Allen, the lead designer of Explorer 1's instruments, von Braun was ready in just 84 days.
2, 1, firing command, firing command.
Explorer 1 took a weapon of war, essentially an intercontinental ballistic missile, something to lob nukes at your enemy. And this converted rocket launched a satellite for scientific discovery.
They wanted to go up there, probably still use the propaganda, but also to use it for science, to really show the world that they were doing it for peaceful purposes.
Among its scientific instruments, Explorer 1 carried a Geiger counter. It confirmed the presence of a large band filled with high-energy charged particles, radiation that had been captured by Earth's magnetic field. Named for James Van Allen, the radiation belts sit high above the atmosphere, shielding Earth from the harmful solar winds.
There are experiments going on right now around the sun to better understand how these radiation belts affect us, because that directly influenced how the future missions were designed to send people past these belts onward to the moon.
On March 31st, 1970, Explorer's journey came to an end after 58,000 orbits. The next goal for both the Americans and the Soviets was to deliver a human to the stars and return them safely.
No one knew what the vacuum of space, the fact that there was no air and therefore no pressure, was going to do. No one understood the temperature ranges. No one understood, could a human survive?
Would a human being's blood not just pool up as little balls in their veins, or would they be unable to swallow? We simply did not know.
Forming in 1958, NASA initiated its human spaceflight program, Project Mercury.
The Mercury astronauts were selected from a very large number of flyers and ex-fighter pilots.
From all of the active duty pilots in the Navy, Marines, and Air Force, the service records of 473 test pilots were selected for review. 110 met the basic qualifications.
You could not just select the average human to go up. You needed someone who has a history of not only the physical effects, but what happens when something goes wrong.
They wanted people that had the right stuff. And out of the thousands of people applied who were tested, went through medical tests and psychological tests, it eventually came down to 7 men.
NASA revealed the Mercury 7 on April 9th, 1959. Following America's announcement, the Soviet Academy of Sciences selected 20 cosmonauts among their Air Force pilots. 6 received accelerated training, and 1 was chosen to be the first man in space, Yuri Gagarin.
Yuri is many things: a brilliant mind, a loyal Soviet. You could not have asked for a more perfect representation of your nation, because he is about to become the most famous man in history.
Gagarin's Vostok 1 was to take off from the same cosmodrome in Kazakhstan that launched Sputnik.
Some rockets accelerate extremely fast, and if you used those for a human, they wouldn't survive the launch. They couldn't take the G-loads. So rockets for humans have to take off relatively slowly, gradually pick up speed.
Within 10 minutes, Yuri Gagarin became the first human to cross the Kármán line, the border between the Earth's atmosphere and outer space.
Yuri Gagarin's flight, Vostok 1, was just incredible. He had a very, very risky mission, but the craft kept him safe and kept him alive, and that was a real technological feat.
The Vostok operated on autopilot, allowing Gagarin to perform tests on the life support and radio.
I think the thing that inspires me most about Gagarin's mission is when he finally got into Earth orbit and he saw the Earth for the very first time, and he spoke back to Mission Control saying, "I see the Earth. It's so beautiful."
The Vostok's single orbit lasted only 108 minutes. However, placing Gagarin in space was only half the challenge. Bringing him home would be just as perilous.
If you're in your capsule returning to Earth, you're going to be careening down through the Earth's atmosphere. And at the speeds we're talking, it's going to generate an enormous amount of heat.
The gas that's right at the nose of the re-entry module can be hotter than the sun.
The re-entry capsule failed to separate from the service module. sending both into a life-threatening spin. Luckily, the friction burned through the cables connecting the two. 2.5 kilometers from the ground, Gagarin ejected. Had he landed inside the Vostok, the force of the impact would have ended his life. Yuri Gagarin's safe return penned a new chapter for the world.
This Russian achievement of landing astronauts safely after orbiting the Earth is really one of the greatest events in the history of mankind. The Russians have succeeded in breaking the barrier which binds man to Earth, and the path is now open for them to explore the solar system.
It was an extraordinary act of bravery that Yuri Gagarin undertook. We knew that humans could go into space and not only live, but survive and possibly even thrive.
A month behind Gagarin's orbit, NASA sent their first man to the stars, aboard Freedom 7.
Alan Shepard was the first US astronaut to achieve insertion into space. He was certainly in outer space, but it wasn't really an orbital ride.
There was no intention for Freedom 7 to complete a full orbit.
All right, lift off and the clock is started.
Reaching an altitude of 187 kilometers, Shepard traveled 486 kilometers from the launch site, splashing down in the North Atlantic Ocean. The entire flight was over in under 16 minutes as planned. America wouldn't attempt their first Earth orbit until 1962. John Glenn's Mercury capsule bore the name Friendship.
Stations, gantry is in launch position. Start interrogation in 1 minute. Godspeed, John Glenn. Roger, 0G, and I feel fine. Capsule is turning around. Oh, that view is tremendous.
John Glenn successfully traversed the globe 3 times.
This is Mercury Control. The Friendship 7 spacecraft is now committed to its 3rd orbit.
Unlike Gagarin's journey, which was shrouded in secrecy, the flights of Shepard and Glenn were broadcast around the globe.
Never in all of history have so many people shared, without censorship, an adventure of such magnitude. Through all news media in all languages, all the peoples of the world are witness to this exploration of space.
Across 3 years, both the United States and Soviet Union completed 6 solo missions, but America still lagged behind. The Mercury astronauts spent less than 54 total hours in space. The Vostok cosmonauts totaled 16 days. The Soviets achieved the next first with the flight of Vostok 6 in 1961.
Vostok 6 was historic. It saw the first female cosmonaut, Valentina Tereshkova.
Tereshkova spent nearly 3 days in orbit. However, the nature of space sickness wasn't fully understood at the time. Ground control was unsympathetic to her condition.
The stories that came back later was that she was groggy, didn't respond quickly to commands, and while she was very much celebrated as being the first woman in space, she was also heavily criticized.
Despite the complications, Tereshkova paved an important stone on humanity's path to the stars. With a dozen single-occupant missions in the history books, the space race competitors strove to increase the size of their crews.
One person can only do so much. And you're going to need support from other people, whether that's for health reasons or different skill sets.
NASA approved the Gemini program 3 months before John Glenn's orbital flight. It would take years to develop a capsule for two.
It's not a linear problem. It's not as easy as simply taking a small spacecraft and scaling it up. The complexities of the aerodynamics becomes quite challenging in achieving the right design for stability and for protection against the thermal conditions.
To ensure they remained ahead of the US, the Soviets retrofitted their one-seat Vostok capsule and placed an extra rocket on the exterior to create the Voskhod.
The need to put more crew meant every single piece of weight had to be justified, to the extent that the crews themselves were even going on diets.
The life-saving ejection seat was stripped, and the Voskhod 1's crew would venture into space without protective suits.
No second chances, no backup. If the pressure of air for breathing was lost, then that would have been it.
Voskhod 1 set a crewed spacecraft altitude record of 336 kilometers. The crew returned safely, but the mission initiated a trend toward unacceptable risks in the Soviet space program.
This is what the space race was about. It wasn't about some high-minded desire to understand the solar system and the universe. It was literally about getting something done before the other nation. And if that meant cramming more people into a sardine can, then that's what you did.
While the Americans prepared for their first two-man team in space aboard Gemini 3, the Soviets sprinted ahead. Crewed by Pavel Belyayev and Alexei Leonov, the second Voskhod mission hoped to achieve the first spacewalk. Voskhod 2 was equipped with an inflatable airlock, facilitating Alexei Leonov's transition into space. Once cosmonaut Leonov exited the craft, he beheld humanity's first unencumbered view of the world.
You're in a capsule. You have very limited amount of material between you and the absolute guaranteed death of space. The thought of then leaving that and trusting to essentially fabric is appalling.
A 5-meter tether was all that kept him from floating into the void.
Alexei Leonov was from the military, so I'm sure he would have been very disciplined about what he was doing.
Leonov later wrote that he felt like a seagull with its wings outstretched, soaring high above the Earth.
He was the first person with an almost perfect view of our planet hanging there.
Taking in this amazing view beneath him, the Earth, our home, the fragile atmosphere that we have, and him linked to a spacecraft by just a tether.
However, Leonov's historic spacewalk quickly turned into a disaster. He noticed that his hands were slipping from their gloves and his boots no longer fit. His suit was expanding in the pressureless vacuum of space. Leonov had only minutes to re-enter the Voskhod before he would be plunged into darkness as the craft entered the Earth's shadow. The cosmonaut vented half his suit's oxygen as a last-ditch effort to reduce volume and regain mobility.
It was a quick decision in the matter of literally minutes. He didn't know if that was the right or wrong answer. He just knew that was his only chance of survival.
The hatch was finally closed. But the explosive bolts that separated the airlock sent the capsule into a spin. The Voskhod would touch down 2,000 kilometers beyond their emergency landing site. When rescue teams finally discovered the crew, they had spent 2 nights in a Siberian forest, enduring temperatures below -25 degrees Celsius.
So the Russians were willing to take more risk up front because they were going to get longer-term reward. That was the only way they were going to establish dominance over the US.
There would be no further Voskhod missions, hinting at an end to Soviet space supremacy. Humanity's foothold in space, however, was not free of tragedy. Both the Americans and Soviets lost lives. In January 1967, 3 NASA astronauts perished when fire erupted inside the Apollo-1 capsule during a ground test. Two months later, cosmonaut Vladimir Komarov, the commander of the Voskhod 1 mission, became the first of the space race to die whilst in flight. Returning to Earth, the parachutes of his Soyuz 1 capsule failed to open. Soviet lunar dreams were suspended for 18 months, during which time Yuri Gagarin, the first man in space, died in a jet crash.
I'm going to step off the limb now.
The following year, America reached the moon.
That's one small step for man, one giant leap for mankind.
Having lost the lunar race, the Soviets shifted their focus toward establishing a semi-permanent presence in orbit. In June 1971, Salyut-1, the premier space station, received its first crew via the Soyuz 11.
There were 7 Salyut space stations that they launched periodically from 1971. They really pioneered another first for the USSR. They really pioneered how to live in space.
If you want to really learn the fundamentals in physical processes, then you're going to have to do an experiment without the gravity. And places like the numerous space stations that have been in orbit give you a convenient laboratory to do that.
In 1973, the United States launched its first space station, Skylab.
Skylab was essentially the answer to the question, what do you do with the Saturn V when you no longer can afford to go to the moon? You use its spare parts to build a space station.
But as soon as the uninhabited station was placed in orbit, it required repairs.
After the launch of the Saturn 1B rocket, the solar panel, one of 2, actually ripped off, and its sunshade, which was to protect the spacecraft from the radiation of the sun while it was in orbit, was also damaged.
The first team deployed to Skylab were tasked with restoring the station.
So the astronauts had to have an emergency repair mission. And that itself was a difficult maneuver. The 2 astronauts outside in a ballet of trying to actually hold one astronaut by the legs while the other was using a long pole with some scissors on the end to cut that cable.
Rotate the pole clockwise. How's that? Okay, that's pretty good.
Eventually, of course, just the ingenuity, the efforts of human beings being up there managed to get the station up and running.
The main operational section, where crews would work and live, was crafted from a refitted Saturn rocket. It had a galley, a zero-gravity shower, and sleeping quarters.
We have 3 bedrooms that we can live in. They're very small. The beds are on the wall as opposed to on the floor, but they're still ample in zero-G.
Every aspect of life had to be navigated in the novel environment of microgravity.
Because there's that lack of gravity, You get fluids that pool in the outer extremities of the human body, in the face and the hands and the feet. The heart muscle is decreasing in size. It doesn't need to work against gravity to get blood from your feet to your head. You get changes to the shape of the eye, which can change your focus. You also get the effects of decalcification in the bones. Your bones don't need to hold you up while you're in space.
Astronauts exercise for several hours a day just to keep their bodies fit and their physiology ticking over. So human beings aren't designed for microgravity, that's for sure.
Skylab remained in orbit for less than a year, while the three teams completed 270 different experiments.
The key experiment that was being undertaken was actually on the astronauts themselves. Can humans remain healthy? Can they remain sane in space?
The third and final crew of the station was so exhausted, they shut off communications with mission control for a full orbit.
The commonly accepted story is that the three Skylab astronauts had just felt they were overworked, so they turned off the comms and they said, "We're out for the day. We're not doing anything, we're not talking to you."
The 93 minutes of radio silence sparked negotiations. The three astronauts received a more lenient schedule and ended up completing all their tasks on their own time. NASA learned a valuable lesson. Their crews had limits. In January 1967, the United States and Soviet Union joined with the United Kingdom to sign an international agreement regarding future space ventures.
The Outer Space Treaty of 1967 was designed to prevent the proliferation of nuclear weapons into orbit and beyond. It was to try to limit the claim staking of governments. In other words, the exploration and utilization of the celestial bodies, the moon and beyond, should be for the peaceful purposes of mankind, for the benefit of all, for exploration.
While the governments of the USSR and US remained engaged in a stalemate, backed by mutually assured destruction. An attempt to de-escalate tensions produced the first united American-Soviet space mission. The Apollo-Soyuz test project would see the two separate spacecraft unite in orbit.
The Apollos and Soyuz scientists are sharing information, so you have to unclassify and share all of your deepest, darkest secrets with the other people in order to make this work. That's the beauty of it, is that they were willing to think beyond the borders of their countries and their philosophical differences to think of a bigger picture, a bigger purpose, which is ultimately the benefit of space exploration in the midst of terrible, terrible times.
Well, I recognize that almost any subject there are differences of opinion. My feeling is that people who understand this mission understand that it is a very fine thing to do for both countries and for the entire world. I think this is a first movement in a direction of joint operations in space in the future.
Both countries launched 7 hours apart.
3, 2, engine sequence start. 1, 0, launch commit. We have a liftoff. All engines building up thrust.
Both control centers, Moscow and Houston, have given a go for docking.
Part of the Apollo-Soyuz mission was essentially to get the command and lunar modules from the Apollo missions and to add a sort of docking platform so that then the Soyuz capsule could dock with those existing platforms.
I got 2 messages for you. Moscow is go for docking. Houston is go for docking. It's up to you guys. Have fun.
How do we dock these two together and what does that look like? What's the interface? Who wants to be the plug and who wants to be the socket? Is there going to be an argument there? I think so, there was. And so they had to completely redesign their approach just to how you attach two things together. They ended up calling it the androgynous peripheral attach system, and it's still used to this day, actually, to dock two things together.
Less than 5 meters distance. 3 meters. Contact. Capture. Tell Professor Bushuyev it was a soft docking.
When the hatch opened, Apollo 10's Thomas Stafford and Alexei Leonov joined hands in the first international handshake in space.
Glad to see you.
The moment when the two commanders actually greeted each other seemed to be heralding a new era.
It really signalled the end of the space race and a new era of international collaboration between nations that had previously kept their programs very secretive.
Over 44 hours, the two teams exchanged gifts, dined together, and conducted joint experiments. After undocking, Apollo eclipsed our Sun, so the crew of Soyuz could study its corona.
The fact that these two former arch rivals in the world of space could come together, it seemed like a pivotal moment in perhaps human cooperation as well as activities in space.
Following the success of their Salyut stations, Soviet plans for space habitation grew more ambitious.
There never will be launch capabilities sufficiently large and powerful to lift an entire space station into orbit.
And so the only way you can get something of significant size up into orbit is to put a bit up there and then slowly add to it.
After the first section of Mir was launched in 1986, 6 pressurized modules were added over the decade.
One of the things that interests me about Mir is that cosmonauts on board the spacecraft actually straddled the end of the Soviet Union, the end of that era.
Sergei Krikalev was on his second tour aboard Mir when the Soviet Union fell.
He was a stateless person in orbit around the Earth, not quite knowing where he belonged.
Serving as the flight engineer, Krikalev agreed to stay and perform the same duties for the next crew.
Flying to Mir as a Soviet citizen and returning to Earth as a Russian citizen.
Falling around the Earth at an average height of 360 kilometers, the name Mir translates to peace.
It was really filled with international projects, and many other nations were invited to take part.
Mir was visited by astronauts from a variety of nations across North America, Europe, and the Middle East, as well as a television reporter from Japan.
And it's wonderful to see a project that was truly international in spirit, going up into space and creating that environment that later led to the wonderful international cooperation that we see today.
However, towards the end of its life, Mir was plagued with hygiene issues.
I think Mir was a little bit like a cruise liner, can be a little bit susceptible to people's infections.
Mir was surrounded by a cloud of little yellow frozen urine drops. Waste management, always a big issue when you're in space.
Urine particles even damaged the station's solar panels.
By the end of the program, in fact, it had to be abandoned, unfortunately. But it was a pretty successful experiment all up. There was a lot of scientific achievements.
By the late 1990s, malfunctions and hazards were mounting. Mold growth, computer crashes, even a fire. The station was abandoned in 2001, left to burn up as its orbit naturally decayed. The same year humans set foot upon the moon, NASA hatched plans to reinvent space transportation.
The shuttle encapsulated the science fiction that I'd read as a kid. A vehicle that would go into space and would land like an aircraft.
It's called a reusable space shuttle, an airplane-like spacecraft that can be hurled aloft by a rocket up to 100 times.
It is actually an aviation system. It generates some lift with its wings and with the underside of its fuselage.
And it just made the concept of going to space so much more accessible.
The challenge there is literally in the reusability. What's going to go wrong over time in doing this immensely difficult thing, technically speaking, again and again, and to be confident that the next time you did do it, everything would still be fine.
Space Shuttle Columbia was ready for the program's maiden orbital flight on the 20th anniversary of Gagarin's journey to space. All subsequent launches would follow the same routine. 2 solid-fuel rocket boosters flanked the shuttle for the first 2 minutes of launch. They would later detach to be collected for subsequent flights. A disposable external tank filled with liquid hydrogen and oxygen powered the shuttle to space. It would burn up during re-entry. In order to withstand multiple journeys through the Earth's atmosphere, NASA engineered a resilient thermal shield. The shuttle's aluminium shell was encased in over 24,000 protective silica fiber tiles. The black tiles on the belly, nose, and wings, where the heat would be greatest, could handle temperatures up to 1,260 degrees Celsius. NASA's fleet of 5 shuttles performed 135 orbital missions over 3 decades. In addition to hosting their own experiments, the shuttles launched satellites and space telescopes, as well as delivering astronauts to space stations. During Space Shuttle Challenger's mission in February 1984, astronaut Bruce McCandless became the first human to float freely in orbit. He performed an untethered spacewalk using a specialized maneuvering unit.
The first untethered spacewalk must have been a terrifying moment. You are your own spacecraft. You are more free than almost anyone could imagine.
Well, it may have been one small step for Neil, but it's a heck of a big leap for me.
While the shuttle program basked in numerous triumphs, it remains mired in tragedy. 2 years after McCandless's spacewalk, disaster befell Challenger, 73 seconds into launch.
Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
A rubber O-ring in one of the solid rocket boosters failed.
And that allowed hot gases to cut through a strut, which was holding on the big external orange fuel tank.
Challenger, go at throttle up.
The entire space shuttle and tank ended up self-destructing.
Flight controllers here looking very carefully at the situation.
The shuttle program endured a second disaster 17 years later in 2003. During Columbia's launch, a piece of foam insulation broke off from an external fuel tank and struck the orbiter's left wing. The heat shield was compromised.
It didn't prevent the space shuttle from safely reaching orbit, but it was a very, very big problem for re-entering.
Yeah, you definitely don't want to be outside now.
As Columbia descended into the thicker atmosphere, hot gas penetrated the craft, causing the wing to tear from the shuttle. Columbia disintegrated, killing the 7 crew.
Space is hard, we say in this industry, and the astronauts paid the ultimate sacrifice. The reverse of that, of course, is the fact that there's so many missions that came after. We learned from those mistakes, we continued to explore, that mission went on. And so I think that that's the best example of what we do as human beings.
While NASA persevered through both tragedies, the Shuttle program never fulfilled its initial promise.
It was a marvelous instrument. It was a fantastic vehicle. It just cost too much to keep reusing.
When first proposed, the cost of a single launch was estimated to be as low as $22 million. In the end, the average cost was $450 million.
For all that, the Space Shuttle could hold its own against any number of the other marvels of the space era.
Space Shuttle Atlantis completed the program's final flight in 2011.
Having fired the imagination of a generation, a ship like no other, its place in history secured, the Space Shuttle pulls into port for the last time, its voyage at an end.
As the 20th century came to a close, construction was underway to facilitate a new age of space cooperation.
302, BP44, 871, 6290.
Astronauts aboard the Space Shuttle Endeavour delivered and connected a station module called Unity to the Russian module Zarya.
Houston Endeavour, we have capture of Zarya.
The International Space Station was born, but it was far from complete.
It took a decade to actually create the full International Space Station, but once the first 2 or 3 components had gone into space, the first solar panels, the first modules, the first power systems, you could put a crew on board. You could start to do the science.
An international community would be invited in. This would demonstrate that collaboration and cooperation was the way space was going to go in the future.
Since November of 2000, humanity has maintained a presence in low Earth orbit, aboard the world's greatest laboratory.
It really opened up space to the world in a way that had never been accomplished before. It just made our ambitions greater.
Following the Space Shuttle's decommission, the Russian Soyuz provided the primary access to the ISS.
The fact that Soyuz has been the workhorse of ferrying both astronauts and cosmonauts up to the International Space Station since the end of the Space Shuttle program in 2011 speaks volumes for the effectiveness and how well designed it was, how well it fits the requirements for a space taxi.
And the hatches between the Soyuz spacecraft and the International Space Station opening.
Could you imagine telling the very first people in NASA in 1950s, in 50 years, you're going to need the Russians to get into space? I think that would be a mind-boggling statement to tell someone at that time.
On May 30th, 2020, astronauts once again launched from American shores. This time aboard a capsule and rocket designed by a private company, SpaceX.
Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX.
Now we're moving into this new era of the commercialization of space, the space entrepreneurs. And so all of these companies and industries are looking at new ways to be able to use the facilities of the space station. That commercialization, of course, will help to fund its future.
The International Space Station has become part of this modern-day movement, or progression really, to democratize space. And what that means is it just gives a more level playing field style of access to space for just about anyone.
The International Space Station is the only place where we can learn what will be required when humanity chooses to venture beyond Earth's orbit.
If, as a race, we are to explore the universe, We need to have the experience. We need to have an understanding of how to handle those extreme environments.
So we're now using the International Space Station as that test ground to see what the effects long-term will be of humans in space, not only the lack of gravity, additional radiation, how do you grow food along the way, how do you survive in a closed environment that has to work perfectly for those future journeys.
The story of the International Space Station will soon come to a close, but its place in the history books will endure as a testament to what a united humanity can achieve. From seeds of rivalry, we have opened a gateway to the cosmos.
In space exploration, we find our greatest challenges and we rise to that challenge.
As we ventured into the unknown, humankind has grasped the impossible.
One of the huge benefits of scientific endeavour is its capacity to bring people together in order to achieve something that has long-lasting impact for the betterment of our society.
Establishing a foothold in orbit, we craft a better world.
It's a keystone for humanity to come together and do something for the benefit of us as a whole.